Good afternoon, everyone. Good afternoon. Hope all is well and everything is all right. Mm,
Good afternoon, Professor.
Hey, hey, how's it going, sir?
Good.
All right, all right. So today, I think we're going to finish up chapter 3. Trying to close out some of these windows real quick. All right, so 245. So last class we did 3-1 and 3-2. There is no 3-3 that you're held responsible for. So we're going to 3-4. 3-4 entitled Measures of Position and Outliers. All right, start off talking about Z-scores. Z-scores will be the distance a data value is from the mean in terms of standard deviations. All right, so the general formula to calculate your Z-score is going to be your data value minus the mean divided by the standard deviation. So all three of these are the same formula, just that this is generally what it means. Here's your population symbols. Here's your sample symbols. Just letting you know, regardless, you have your data value minus the mean divided by the standard deviation. Scrolling up. Few characteristics of your Z-score is unitless, and it has the mean of 0, standard deviation of 1. Eventually, when we get to the Z-score chart, you'll see how your mean is in the middle, and when you convert that mean to a Z-score, it's 0, and standard deviation is 1. So, and if I'm not mistaken, my math lab, they ask you, that statement about 0 mean being 0, standard deviation being 1. But that'll make more sense when we get to our Z-score chart, which is something that we'll use, in a few sections later. Not in this chapter, but in a few sections later. And it applies to that normal distribution. All right, scrolling up. All right, so here we want to determine whether the Angels or Rockies had a relatively better run producing season. The Angels scored 773 runs and played in the American League, where the mean was 677.4 and the standard deviation was 51.7. The Rockies scored 755 runs and played in the National League, where the mean was 640, standard deviation was 55.9. Give you a chance to write that down for those who are writing it. All right, again, so we have the Angels that scored 773 runs. Notice if you don't know a lot about baseball, notice you talked about American League versus the National League. The American League has a little bit different rules than the National League, so that's why you can have a different mean and standard deviation in the American League versus the National League. So the Angels are in the American League, and so we want to see what was their score, what was their run producing in comparison to the averages in the American League. Then we'll look at the same thing with the with the Rockies in comparison to the National League. So we gather the information. Whenever dealing with word problems, I always say write down all of your given information first before you start trying to do calculations. So the data value in question for the Angels is 773 because that's how many runs they scored during the season. The mean for the Angels will be 677.4, and then standard deviation is 51.7 because the Angels was in the American League. The Rockies, 755 is the data value. 640 is the mean of the National League, and then 55.9 standard deviation of the National League. So all we did was write down the given pieces of information. Then from there, we can calculate the Z-score for each. Anybody, if I'm going up too far, let me know. So for the Angels, 773 minus 677.4 divided by 51.7 gives us 1.85. Then for the Rockies, 755 minus 640 divided by 55.9 gives us 2.06. So those are our Z-scores for each team respectively. And so you notice this statement here, always round your Z-scores to 2 decimal places. That's going to matter. I talked about the Z-score chart. It's going to matter then. Round your Z-scores to 2 decimal places. Any questions before we get to our conclusion? So we see our statements here. The Angels scored 1.85 standard deviations above the mean. The Rockies scored 2.06 standard deviations above the mean. So notice I underlined above because it is possible for your Z-score to be negative. That means you would have scored below the mean. So the positive or the negative Z-score does matter. So because both of our values are positive, that means that they scored above the mean. Mm-hmm. All right. And that means the Rockies had a better run producing year. Any questions? Any questions? All right, can I scroll up? All right, next thing is percentiles. And like I said, going back to Z-scores, that's all they really talk about as far as Z-scores in this section. We will look into more applications of Z-scores later on, but they just want to introduce it to you right now. So percentiles, the kth percentile of a set of data is a value such that k% of the observations are less than or equal to the value. The kth percentile is noted is denoted as P sub K. So PK. All right. So an example of this, Jennifer just received the results of her SAT exam. Her SAT math score of 600 is in the 74th percentile. What does this mean? All right, everybody done with black? All right, so 74 percentile means that 74% of the people who took the exam scored 600 or less, and then 26% scored better, and we get that 26% from 100 minus the 74. Any questions? Any questions? As always, if I scroll up too far, let me know. All right, next part is the quartiles. Not 7-4, but 3-4 and 3-5 really flow together and roll together, especially once you get into quartiles, because 3-5 is just adding one more step to what we finish off 3-4 with when we deal with these quartiles. So what you'll see when we get there, quartiles divides the data set into fourths. So notice you have your minimum and maximum value as your bookends, but then you have Q1, Q2, and Q3 that splits up your data. Those are your quartiles. All right, so to find our quartiles, first thing you want to do is list your data values from least to greatest. Never forget this first step. A lot of people make a mistake and forget that first step, And of course, you can get all your values wrong from that point forward. You got to hold on to that first step, list your data values from least to greatest, or at least make sure that your data values are listed from least to greatest. We'll find Q2 first. Q2 is going to be the median of the whole data set. So it's just the middle value of the whole data set. That's going to split your data in half. Then you'll find Q1, which is going to be the median of your first half of data. Then Q3 will be the median of the second half of data. So remember last class we were talking about finding the median. The median is just your middle values. And so we're looking at, all we're doing is looking for medians. Q2 is the median of the whole set of data. So it's going to split your data in half. Looking at your first half of data, Q1 is the median of the first half of data. Then that second half of data, Q3 is going to be the median of that second half of data. Any questions? All right, scroll up. Next thing is your interquartile range. So that's just the range of the middle 50% of the data. And we can find that by taking Q3 and subtracting Q1 from it. That will be the range of your middle 50% of data. All right. So we're gonna run through all these steps and then we're gonna do them all together, step by step. So I'm just giving you all the information. Then we're gonna do a problem that involves all of these things. So next thing is checking for outliers. So outliers are extreme values. Now, I wrote in a circle, they could be small or large. I don't know why I wrote that small like that. But they can be very, very small or very, very large. But they're extreme values in reference to the data set. All right, so to calculate your upper fence, Q3 plus 1.5 times the IQR. 1.5 is just a part of the formula. So make sure you use the 1.5. And then your lower fence is Q1 minus 1.5 times the IQR. IQR. Right. So the reason for these fences, if a data value is greater than the upper fence, it is an outlier. If a data value is less than the lower fence, it is an outlier. Any questions? Can I scroll up? All right, so I'm going to walk through the steps. So we go to step by, if you do this step by step, then we'll set you up to be able to find your quartiles, any outliers, all the good stuff like that. So is everybody good with that? All right. So let's look at this first example here. I'll give you a chance to write it down. Let me erase some of this stuff. All right. So we have 18 values. I went ahead and listed it from least to greatest. Your data values, of course, does not have to be given to you, written from least to greatest. You may have to do it yourself. I went ahead and did this, and notice how I labeled or wrote them out. It was 18 values, so I wrote 9 and then 9. I broke it up in half. So when I listed them out, I listed them out in half just to help me with breaking up my data set. You don't have to do that, of course, but you do have to list it from least to greatest. But I think it is to your benefit to go ahead and break it up into the first half of data, second half of data. So once again, I counted off my data values. I had 18 data values. So I wrote the first 9, then I wrote the second 9. Any questions on that? Oh, just reading off the data values. That's 180, 189, 370, 618, 735, 802, 1185, 1414, 1657. Then the second half is 1953, 2332, 2336, 3461, 4668, 6751, 9908, 10,034, and then 21,147. All right, let's see if I can put my. All right, so we have 18 data values. The first thing we'll do is find Q2. So don't forget, if you have an even number of data values, you have to take the 2 middle values, add them together, divide by 2. And that's what we did here. I took my 2 middle numbers, which is 657 and 1953, add them together, divide by 2. And that gave me 1805. Remember, Q1, Q2, and Q3 are just medians, just our middle values. All right. Q1, no calculation needed because I have 9 data values. That means I have an odd number. Since I have an odd number, that means I do have a legit middle number, which is 735. So if you were to look at this first half of data, the middle number of the first half of data is 735. But once again, let's say if I had an even number in my first half of data, then I have to do like I did here, take the 2 middle values, add them together, divide by 2. No, I don't need that. Q3, middle number of the second half of data, and that's 4668. All right, any questions on steps 1 through 4? All right, not test 5, but step 5, find the IQR. That's just taking Q3 and subtracting Q1 from it. And that gives us 3933. All right. Now we can establish or determine our fences. Anybody holding on to Q3, number 4? All right. So our upper fence, Q3 plus 1.5 times the IQR, so that's 4668 plus 1.5 times 3933. That gives us 10,567.5. And our lower fence doing Q1 minus 1.5 times the IQR ends up being negative 5164.5. Any problems? So now that we have the two fences, if anything is greater than 10,567.5, then it's an outlier. If anything is less than negative 5,164.5, it is an outlier. So we go back to our data set and we check that out. And yes, we do have an outlier, 21,147. And that's because it is greater than our upper fence. Any questions? Any questions? All right. Any problems? Any problems? Before we go to the next thing, make sure we're good. All right, so that's it for 3-4. Are we okay to go to 3-5? All right. So 3-5. Really, like I was mentioning before, 3-5 is just an extension of 3-4. Hold on one second. All right, so sorry about that. 3.5 is just an extension of 3.4. We have the 5-number summary and box plots. So first thing, recognize we have 5-number summary. Those are the same values that we talked about before. You know, the split of our data into 20, to fourths. So our minimum, Q1, Q2, Q3, and our maximum. All right. And box plots is the next thing. It actually uses these values as a graphical tool used to compare groups of data. And it consists of a box with lines that extend to the minimum and maximum values that are not outliers. So I'll show you what that means in a second. Everybody jump to purple. So these lines are called whiskers, and outliers, any outliers that we have are represented by an asterisk. All right, here's a generic example of a box plot. So you have your minimum, where you have Q1, Q2, Q3, which make up your lines of your box plot, of your box. And then you have these whiskers that extend out to the minimum and maximum value that are not outliers. And then we represent our outliers as just asterisks. Any problems, any problems? All right, so a problem out of here that pretty much summarize everything that they talk about in this section is give the 5-number summary and then sketch the box plot. So in red, just stating, once again, your data set is not always written from least to greatest. Make sure this is the case before you move forward. So it's always going to be your first step. Write your data set from least to greatest. All right. So here are our data values. And I'll erase this initially. So we have 21 data values altogether. So just like before, I split my data as I'm listing them out, I split them up in half. So if we have 21 data values, that means I have 10 in my first half of data, a legit middle value, then 10 in my second half of data. So that's why I broke it up this way. So that's 1995, 2325, 2332, 2555, 2583, then 2628, 2858, 2872, 3018, 3035. Then you see my middle value, the 11th number is 3095. Then at the bottom half, we got 3213, 3323, 3353, 3668, 3705, 3743, 4142, 4247, 4917, and then 5463. Right. Any problems before we go to step 2? Make sure we're okay. All right. So once again, I have 10 data in my 10 data values in my first half of data, 10 data values in my second half of data, but I have a legit middle value because I have 21 data values altogether. So remember, your median is just your middle value. And so that's going to be 30.95 for Q2. That splits my data set into half. Now Q1, because I have 10 data values. Oh, hit my eraser one. Because I have 10 data values in my first half of data, that's an even number. That means I need to take my two middle values and divide that by 2. So that's how I get 26.06 for Q1. Q3, we have to do the same, take the two middle values, add them together, divide by 2. That gives us 37.24. Any problems? So step 5, find the IQR. So we'll take Q3 minus Q1, 11.18. Any problems? So next thing we'll do is establish our fences. Sometimes some books refer to them as limits, left limit, right limit, but our book called them left fence of upper fence. I think I was talking to another class when I mentioned that, but our fence is left fence, lower fence, upper fence. So to find our lower fence, Q1 minus 1.5 times the IQR. So it's 26.06 minus 1.5 times 1118, which is 9.29. And then our upper fence, Q3 plus 1.5 times your IQR. That'll give us 54.01. Any problems? So just reiterating why we finding these values. If a value is less than the lower fence or greater than the upper fence, then it is an outlier. So now we determine if we have any outliers by comparing our fences to our data set. And so 54.63 is an outlier because it is greater than the upper fence. Any problems? Any problems? All right, so now we have enough information to establish our 5-number summary and box plot. So 5-number summary, so the minimum value, 19.95, Q1, 26.06, Q2, 30.95, Q3 is 37.24, and then your maximum value, which is 54.63. So this right here has nothing to do with anything being an outlier or not. Just what is your minimum value? What is your maximum value? Q1, Q2, and Q3. Any problems with the 5-number summary? All right, then the box plot. We have Q1, Q2, and Q3 right here. And then these whiskers extend. Whiskers extend to the maximum value that is not an outlier. So that's why our largest value that's not an outlier was 49.17. So that's why the whisker extends to 49.17. And then we represent 54.63 with an asterisk. Questions? Any questions? Everybody good? Everybody straight? Mm-hmm. All right, so as far as chapter 3, that's it for chapter 3. Is everybody done with copying before I scroll up? All right, let's see what I want to talk about here is. All right, so here we go. So what you guys are held responsible for at this point, as far as homework in math lab, you have chapter 1, chapter 2, and chapter 3. All right. Now there's a test that's already posted that's on chapter 1 and 2. That's just test 1. And then don't forget those definitions if you haven't sent them to me already. A lot of you have already done so. Questions on what you held responsible for? Any questions? Any questions? All right.
So when you said the test was posted, that's just to like keep us on track, right? Like it's technically still due the 17th of December.
Yes. Right. Mm-hmm.
Okay.
Yeah.
Right,
so yep, no, not a problem. So yeah, and I'm glad you mentioned that. So the due dates for everything is 12/17. But of course, you don't want to wait till December to start working on this stuff. And not saying that he was suggesting that, I'm just, saying it for the room. You want to make sure that you guys are progressing throughout the course as we progress through the course. So notice we close out chapter 3 today. And that's why, and we're going to stop right here because, if I keep going, we got over till 3 o'clock or something like that. I can put a whole bunch of content in that. And of course, I don't want to do that and overwhelm you guys with information. So that's why we're going to pause right here as far as lecturing is concerned, because you have 3 chapters that you are responsible for. But as we progress throughout the course, you want to be doing the same thing. And if you ever want to know if you're on track, then you just gauge yourself according to the lectures. If I close out a chapter, that don't mean you necessarily have to be done with chapter 3 with your homework, but you should be in there doing work to get ready to close out. So you always want to gauge yourself according to the lectures, and that will let you know if you're keeping pace with what's going on. So don't forget, we only have 8 weeks to cover the material that we have. And I'll do my best to pace this thing so that you're not getting a whole bunch of stuff at one time. But at the same time, we don't really have the luxury of not doing stuff too often. So in chapter 4, it's only 4:1 through 4:3. So it's only 3 sections in chapter 4. So you most definitely want to make sure that you stay on task, because next thing you know, we'll be sitting in chapter 6 and you have a whole bunch of stuff looking at you. So any questions on anything over there? Here, I was just pointing out that test 2 isn't until we close out chapter 4, so you don't have to worry about second test just as of yet. So any questions, concerns, comments before we, close out today? Anything, anybody? Okay. So like I said, I'm not going to hit anything else new today. I believe you guys have enough that you have to, knock out. So you have 3 chapters. So we'll pause right here as far as lecture is concerned. Next class, once again, it will be an opportunity for you to ask questions. We'll get into chapter 4 and then once again, open the floor for any questions that may have been generated over the weekend. All right. Everybody good before we close? All right. And since I have time, I can go ahead and get this lecture out to you guys for anybody that need a review. So I'll shoot that out to you within the hour. You have to wait for this to convert, of course. Other than that, you guys have a great weekend. Be safe. And I will see you on Monday.
Thank you, Professor.
All right. Thank you. Take care. Have a good one. Take care.
Thank you.
Thank you. Have a good one.
You too.